Illustrative Math, Algebra 2, Unit 5, Lesson 2 is called Moving Functions. All right, so our goal today is I can use function notation to represent a vertical or horizontal translation from one graph to another. So vertical obviously is up and down like that. Horizontal is left and right like that. Okay, so I would recommend pausing the video here and jotting this table down somewhere in your notes. This is not in your book. This is something that I've used over the years. I think it's very helpful. So go ahead, pause the video and jot this down. All right, so vertical shifts. So if I want to shift a graph up, okay, this is really up is what this is, and this is down. I just add the number on to my function. Okay, and what will happen on the graph is the graph of f, raise the graph of f by c units. So basically just add c to the function. Now, if I had a table here, if I had like an XY table, if I had like 2, 3, 4, and then say these numbers were, I don't know, let's say 2 squared, 3 squared, 4 squared. If I wanted to, shift it up, I would just add c to all these y coordinates. Usually it'll be a number. It'll be like, move it up 3 units. Okay, so I'd add 3 to all those numbers. Okay. And then down, you're going to lower it obviously, and you're going to subtract from your function. Okay, so in this case, it'd be minus c from all those there. If you had to shift it down, it'd be minus c. Okay. Horizontal, a little tricky. So left, a lot of people think, oh, it's going to be x minus c, but it doesn't work like that. You're going to replace the x with x plus c. Okay. Now it still works the way you would think in a table. If you had a table here, let me erase this. I want to leave a little more space. If I have an XY table here, I'll use the same numbers, 2, 3, 4, 4, 9, 16. Let's say I want to go like left 2. Still what you think like, oh, I subtract 2 from x because all your x's are moving left 2. It's just with the function, it has to be replacing x with x plus c. And then same thing here with right. Okay, it's x minus c, but it's still the same thing. You'd add x to the coordinates. So if I change that to right 2, you'd add 2 to all the x coordinates. But if you had a function, you'd have to replace x with x minus 2. All right, so here's a quick example. Here's f of x equals x squared plus 5x minus 1. Find a new function g that satisfies the transformation. So up 6. So you're going to take f of x, you just add 6. So we'll call it g of x, x squared plus 5x minus 1. This is my f of x, and then I'm going to plus, not 1, plus 6. Okay, just erase it and try it again. Okay, so then these are like terms here, so what you end up with is g of x equals x squared plus 5x plus 5. Okay, so that's your new function. Now, if I went down 6, it would be, I'll tell you what, I'll just clone that here. So if I go down 6, it's going to kind of be the same thing, except I have to minus 6 here. So this one would be x squared plus 5x minus 7 once I combine those two like terms there. Okay, so right 6. So I'm going to replace x with x minus 6. So here's what I'm going to do. I'm going to take this over here as well. And instead of x, I'm going to replace it. All my x's, I'm going to replace with x plus, or x minus 6. I said plus 6. It's going to be x minus 6. We're going to find f of x minus 6. So g of, you know what, I should have made that f of x. Because g of x, it's not g of x until well, no, I guess it was g of x. I started with f of x and then I minus 6, so it ends up being g of x. So this is going to be f of x minus 6 instead of x. This is going to be x minus 6 squared. And this is going to be 5 times x minus 6, and then I didn't have enough room, so I erased it. So I could simplify that. I could do x minus 6 times x minus 6. I could distribute this and combine like terms. I'm not going to for now. I'll just show you how it is right there. So this is going to be, I'm going to find f of x plus 6. So it's kind of the same thing here. So g of x would equal, instead of x squared, it's x plus 6 squared plus 5 times x plus 6. And then you still have the minus 1. Okay. And again, I could simplify that out and combine like terms, but I'm just going to leave it. So that's kind of what we're going to do today. All right. So it's important to have this table. It'll be very, very helpful. All right. Graph each function using technology. Describe how to transform to get the function shown here in terms of both the graph and the equation. Okay, so if this is my original, this is my f of x. So if I look here, it looks like the only thing I did here was like this is f of x, but then it looks like I just minus 5. So it looks kind of like it's f of x minus 5 because this is f of x. So it's like this is my f of x right here, and then you just minus 5. So if you go back to your table, f of x minus c, it's going to go down. So it's going to go probably down 5. Okay. And now this one's a little bit harder to see, but if you look here, at the original here, we have x squared. So think of this as your x squared, but it's like I subtracted 4. And then here, this is x minus 2. It's almost like I subtracted 4. It's almost like I replaced the x with, let me come down here. So instead of x squared, it's x minus 4 squared. And then instead of x minus 2, it's almost like it's x minus 4 minus 2. And then if you get rid of these parentheses and combine those terms, it's almost like how they get the x minus 6. Okay, so it looks like we replaced x with x minus 4. So if I go back to my table here, x minus c, that's going to shift it right 4 units. Okay, so x is replaced with x minus c. So this is going to go right 4. Okay, and let's take a look at the graph and see if we were right. So here's my original. The original is the blue. So let's do this. I'll trace it in red. Okay, so I thought to get here, I go down 5. So I'm going to kind of go right here and I'm going to move it down to -5. And it looks pretty good. Okay. And then if I wanted to move it right 5 to get this function, let's see if it does it. Sure enough, right 5, I got that function. Okay. Or I get that graph from the function. All right, so you can always kind of type these in on graphing calculator to double check things if you want. www.desmos.com if you're not familiar with it. Um, Great graphing calculator that's free to everybody. All right, so graph of function g is a vertical translation of the graph of polynomial f. So here's g, here's f. Okay, so it looks like they're the same graph. It just looks like it's translated up. Okay, so I guess the best thing to do is find x's that have the same coordinates. So the best points to or find points that have the same x coordinates. So this has a -4 here, and then this is up here at 4. So it looks like it just shifted up 4, okay? So it looks like I went up 4. If I trace this graph here and I shift everything up 4, it looks kind of like the same graph for the most part. So up 4, what do I do to my table if I go up 4? If I go up 4, I add 4 to the y coordinates, okay? So if I wanted g of x here, I would just add 4 to all of these. So that would give me 4. This would give me 0.7. That would be 4, negative 1.8. And then this would be 4. Okay, so there's that. If f of 0 equals negative 0.86, what is g of 0? Well, you'd add 4 to it. You'd add, because this is the y. X is 0. This is your y coordinates. We'd add 4 to that. So it'd be negative 0.86 plus 4. So I would get, what is that, 3.14, because you're adding 4 to the y coordinate. Write an equation for g of x in terms of f of x for any input. Okay, so g of x is going to be your f of x function plus 4. So h is over here. H is equal to f of x minus 2.5. So that's going to go down 2.5. So we're going to subtract 2.5 from all the y coordinates. So this is going to be negative 2.5. This is going to be negative 8.3, negative 2.5. This is going to be negative 5.8, and negative 2.5. All right, sketch your graph of h. So I guess I'm going to, tell you what, I'm going to copy this table to the next page. I'll make it a little bit easier to graph. All right, so I'm graphing h. So my x's are right here, and these are my y's. So negative 4, negative 2.5, negative 3, negative 8.3, negative 0.7, is that negative 2.5? 1.2 is a negative 5.8, and then 2 is at negative 2.5. All right, so I got enough points. I'm going to connect the dots. Always go from left to right. So it's going to be something like that. Okay, put your arrows on it. There it is. All right. Write an equation for g of x in terms of h of x. So g of x. Okay, so in terms of h of x, so g of x was for up from f. Okay, so to get f was all the way up here. So like, let's say f was here, and then g was up here at 4. You'd have to add the 2.5, or the negative. You have to add 2.5 here, and then another 4. So it would be like h of x plus 6.5. Okay, because you'd have to move it all the way up to there, which is 6 units. If I You might be able to see it better if I do this. If I put this point right here and I say, okay, that point's got to get all the way up to there. So that I move the whole function like that. So it's going up 2.5 and then another 4, so 6.5 to move h. Okay, a bakery kitchen has a thermostat set to 65 degrees starting at 5 a.m. The temperature in the kitchen rises to 85 degrees when the ovens and other kitchen equipment are turned on to bake the daily breads and pastries. The ovens are turned off at 10 a.m. when the baking finishes. Sketch a graph of the function h that gives the temperature in the kitchen in degrees Fahrenheit, X hours after midnight. Okay, so let's think about this here. The temperature is at 65. So basically 65 until what, 5 a.m.? Whoops. So it should look like that. And then they turn them on to 85 when the ovens in the other kitchen are turned on. And then they turn it off at 10 a.m. So basically, it's going to take a little bit of time to go up. 10 a.m., they turn them off. So probably going to shoot up like this. I don't really know, but it needs to get to 85. And then it's going to stay flat up here at 85, probably. If I can click on that. And then at 10 a.m., they turn them off. So it's going to start going back down. And then eventually they'll cool down and the room will stay at 65 degrees. Okay. So it should look something like that. Notice, let's see here. Let me double check everything. So yeah, this point is when at 10 a.m. when they turn the ovens off. So the room starts going back down towards 65. When they're cooking, it stays up here. This is right when they turn the ovens on and they're warming up. And there we go. All right. All right, let's go to the next question. The bakery owner decides to change the shop hours to start and end 2 hours earlier. This means that the daily baking schedule will also start and end 2 hours earlier. Sketch a new graph of that function. Okay, so everything's going to move left too. Okay, so let's do this. I'm going to screen grab this. I'll just put it right here. Okay, so that's the original. So what I need to do is if I'm going to start 2 hours earlier, everything basically has got to move to left. So here's what I'm going to do. I'm going to trace it. I'm just going to move everything to left. So I'm going to take this point here. It was at 10. And move it right there to 8. Okay, everything moved to left. All right. So the blue one will be G. All right, explain what h of 10.25 equals 80 means. So I would say that means 10.25 hours after what was it, 5 a.m.? Let me look back here. Yeah, so I would say 10.5 hours after 5 a.m. Temperature in the room is 80 degrees. Why is this reasonable? Well, when I look at my graph here, and I'm looking at for H is the black graph. So at 10.25 looks pretty good. Yeah, it looks like it's right at about 80. Okay. Obviously, it's hard to tell exactly. It's somewhere over here. Okay. And if h of 10.25 equals 80, then what would the corresponding point on the graph of G be? Well, it'd be 8. It'd be this point right here, because this point moved left there. Okay, so it would be G of 8. So I'd say G of 8 equals 80. Okay, now notice we moved to left. Okay, write an equation for G in terms of H. So G of H so G is to left. So we need to in order to shift it left, we'd have to add 2. So it's going to be H of H plus 2. Okay, and that'll shift it left 2. Okay. Maybe I should have used X. Let's use X. All right, so think about it. And a lot of this is confusing, but look here. So to get G, okay, you would have to add 2 to the X coordinate to get the same coordinate on H. Okay, I guess I should have written H here in black. Okay, so they're 2 off. So I'd have to add 2 to that function. Okay, or you could just think of it as, oh, I had to shift it left 2, so I had to do the opposite there. All right, so keeping your work hidden from your group, draw transformations of F and name it on G. Okay, so here's my F. So if I wanted to go, I don't know, let's say right, let's say up 2. So let me trace this. All right, so if I want to go up 2, I'm going to pick this point right here, and I'm going to go up 2. So that point is 2, 4. So it would be like right about there. So let's write that down. So I translated F up 2 units. Okay, write an equation for G in terms of F. So G of X is going to equal F of X. I don't really know the function, so I'll just call it F of X plus 2. Okay. Now, if I wanted to maybe do a horizontal, let's say I wanted to go right 4. So that 2 is going to go here to 6. Okay, so I guess I'll put it over here on the G graph. All right, so if I wanted to do another one, right, so that'd be right 4 to get to 6. Right 4 would be G of X equals F of X minus 4. Okay. So our goal, I can use function notation to represent a vertical or horizontal transformation from one graph to another. Make sure you have that table from the from the second slide. All right, here's a function of F and graphs of two transformations of F. So G and H. Okay, so here's my original. This is my original. And then these are my transformations. So first of all, let's figure out how to get there. So like find a point on G that corresponds. Like maybe like this point right here would kind of be an easy one to find. If you look here, I went from -2 up to 0. So it looks like it went up 2. So it looks like I translate F up 2 units to get G. So my function is going to be G of X equals F of X plus 2. You add 2 to move up. Now, for this one, it looks like that point moves left 1. So for H, translate F left 1 unit to get H. So I'm going to say H of X is equal to F of X. So to go left, I'd have to replace the X with X plus 1. Okay, and that would be my new function. All right, so that's all for this lesson, and thank you for watching, and I hope you enjoyed it, and we'll see you next time.